everyone, my name is Shivani Mam and today we'll start with our lecture 3 of Rational Numbers class 8th. So in today's lecture we will cover lowest form of a rational number, absolute value and comparing two rational numbers. So let us start with the first topic. So our first topic is lowest form of rational number. Alright, they are also known as reduced form, standard form or simplest form. Alright, they are synonyms of each other. Okay, and they have the same meaning. Alright, let's move to the next point. Next point is definition. So a rational number p by q is said to be lowest form or simplest form if the denominator, that is q. Alright, this q is a denominator. This denominator, that is q, is positive. Alright, our denominator should be positive. And p and q have no common factor. No common factor other than 1. Are relatively prime. Alright, so let us understand this definition. Alright, for example 5 and 7. Right, 5 and 7. 5 by 7 I am writing it over here. Now 5 comes in a table of 1 and 5. Isn't it? So here 1, 5 and 7 comes in a table of 1 and 7. Alright, so these are the two factors of 5 and 7, isn't it? So, are there any common factor over there? Yes, 1, isn't it? So, they have only one common factor, that is 1. So, therefore, highest common factor HCF is equal to 1. Alright, so here they are in standard form. Alright, they can't be further cut. Alright. And here denominator is also positive. Alright. This 7 should be positive and it's already positive over here. Right. Now let's move to the another example. Like for example 10 by 18. Alright. So 10 by 18. Okay. 18 is positive. Our first step is done. Okay. Now about 10 and 18. They both comes in a table of 2. Alright. Then it comes in a table of 5 and it comes in a table of 9. Right. So, can you see any common factor over here? Yes, we can see it. That is 2. That is 2. So, here highest common factor is 2. That is, they can be cut. Isn't it? They comes in a table of 2 there, so that we can cut it. Right. So, cut this 10 by 2 and I'll get 5. And cut this 18 by 2 as well, I'll get 9. So here I got 5 by 9 and this is the standard form of 10 by 18. Alright, because 5 and 9 can't be further cut. They don't come in a common table other than 1. Alright, so this is the standard form. Just start cutting numerator and denominator with common tables in which they come together. And so far that they can't be further cut. Alright, so here it is 5 by 9 and 5 by 9 is the standard form. So I hope this example is clear to you. Let's move to the next point. So for example, there is an example given to us, the rational number 3 by 5. Alright, 3 by 5 is in the lowest form, isn't it? It is in the lowest form because 3 and 5 can be further cut. Right, 3 comes in a table of 1 and 3, 5 comes in a table of 1 and 5. So they come in a table of 1, that is common between them, isn't it? So they can be further cut. So that means they are in the lowest form. Alright. Because 3 and 5 have no common factor other than 1. Alright. So I hope this example is clear to you. Let's move to the next example. So however, the rational number 18 by 60. 18 by 60 is not the lowest form because they can be cut by 6. Alright, they both comes in a table of 6. So we can cut 18 by 60. So 18 by 60 can be further cut. They comes in a table of 6, isn't it? So they can be cut by 6. So here 6 3s are 18 and 6 10s are 60. So 3 by 10. 3 by 10 is the lowest form of 18 by 60 because 3 by 10 can't be further cut, right? So here, because 6 is a common factor to both numerator and denominator, so they are not in the lowest form. So I hope these two examples are clear to you. Now let's move to the questions. Alright. So our first question is express 24 by 84 in standard form. Alright. 24 by 84. Now they comes in a table of 2. Right. So here just identify the smallest table in which they come together. So they comes in a table of 2. So let us divide them by 2. So here 2 12s are 24. Then 2 it will be 42. Alright. Now 12 and 42. 12 and 42 also comes in a table of 2. Isn't it? So here 2 6 are 12 and it will be 21. Right. Now 6 and 21. 6 and 21 comes in a table of 3. Right. They comes in a table of 3. So here let us cut them by 3. So 3 2s are 6 and 3 7s are 21. So this 2 by 7. Can I cut 2 and 7 further? No. Right. They doesn't come in a common table other than 1. So therefore our standard form is, our standard simplest or reduced form is 2 by 7, and that is our answer. And we are not concerned about denominator over here because it is already positive. Right. So I hope this question is clear to you. Let's move to the next question. So our next question is express 91 by minus 364 in standard form. So here 91 by minus 364. Now the main concern is that our first step is to make denominator positive, isn't it? So step over here is make denominator positive. Right. So how we will do it? So for that there is a trick over here. Alright. So here let us understand the concept first and then we follow the trick. Alright. So here 91 minus 364. Alright. Now what I have to do? I have to make the denominator positive, isn't it? So what should I do? I'll multiply it by minus 1. Right. So here let us multiply it by minus 1. So if I multiply minus 364 by minus 1, I have to multiply 91 by minus 1 as well. Right. When we multiply numerator by some number, I have to multiply it by denominator as well, so that the value of fraction remains same. So here minus 1 divided by minus 1. So here 91 into minus 1 will be minus 91, and here minus 364 into minus 1 will be 364. Right. So here my denominator got positive and numerator got negative. Alright. So now I got my trick, that how we'll do it. If I want to make this denominator positive, alright, so I'll take this minus sign to the numerator directly. I'll just know that how it comes, so I do it directly. Alright, so here if I want to make the denominator positive over here, minus 7. So what I'll do, I'll take this minus to the numerator and I'll write it as minus 5 by 7, because simply we'll multiply it by minus 1 on minus 1, and this 5 will get negative and minus 7 will get positive. Alright, so we have to do this step directly. Alright, so here 10 by minus 5. So I have to make this denominator positive. What I'll do? I'll take this minus sign to the numerator and it will be minus 10 by 5. Alright. So I hope this point is clear to you. So now I am writing it over here, minus 91 by 364. and our first step is done. Alright, so denominator got positive. Now I can't find the common factor because the numbers are too big, isn't it? And it is not divisible by 2, it is not divisible by 3 as well, not by 5. Then how we will proceed, isn't it? So when we don't find a particular factor, just factorize it. Alright, just factorize the 2 and you'll get your answer. Alright, so I'm starting with 364. So here I'm factorizing 364. Alright, so here 2, it will be 182 to 91, and yes, I got my 91, isn't it? I can write 364 as 2 into 2 into 91, and I'll keep my 91 over here. Right. So now I got this. 91 get cancelled by 91, and what I'll get in the numerator, I'll get 1. So here minus 1, 2 2s are 4, and this minus 1 by 4 is the standard form because it can't be further cut. Alright, so whenever you feel difficult to find the factors which is common in both, just factorize it. Alright, just factorize the numbers and you'll get your answer. Alright, so I hope this question is clear to you. Let's move to the next question. So our next question is minus 13 by 81. Alright, minus 13 by 81. So here what I have to do, I have to make the denominator positive. So step 1 is still the same. Make denominator positive. Alright. So here minus 13 by 81, and this minus will get cancelled out and we'll get 13 by 81. Isn't it? Our work is done. Now what I have to see whether it is in the lowest form or I have to convert it into lowest form. Alright. So now I'm again confused about the factors, right? Common factors. So I'll factorize them. Alright. So 13 comes in the table of 1 and 13 because it's prime. And 81 comes in the table of 3. So 3 into 3 into 3 into 3. Now, can we see any common factor other than 1? No, we can't see any common factor other than 1. So, we can't cut it further, right? So, here I'll write 13 by 81 is in the standard form. Alright, so I hope this question is clear to you. Alright, so here there are some notes that we have to study. So let us start. Alright, so here our first note is two rational numbers are equal. Two rational numbers are equal if they have same standard form. Alright, if they have same standard form. So let us understand this point now. Alright, for example 16 by 20. Alright, 16 by 20 and 12 by 15. Alright, these are the two rational numbers and I have to find whether they are equal or not. Alright, so let us just convert these two in standard form. So here they are divisible by 4, right? 16 and 20 comes in a table of 4. So just divide them by 4. So it is 4 and 4 5s are 20 and it will give me standard form as 4 by 5. And in a similar way, I'll divide 12 by 15. They comes in a table of 3. So here 3 4s are 12 and 3 5s are 15. So here they both have same standard form. They can't be further cut, right? 4 and 5 can be further cut. So the standard form of both the rational number are same. That means they are equal. Alright. So I hope this point is clear to you. Okay, so let's move to the second point. If x by y is a rational number and m is any non-zero integer, alright, m is any non-zero integer, then x by y is equal to x into m upon y into m. If x by y is a rational number and m is any non-integer and m is any non-zero integer, then x by y is equal to x divided by m, y divided by m. Alright, so let us understand these 2 points together. Alright, so here these 2 points means that when we divide any rational number with same number, or when we multiply the numerator and denominator of a rational number with same number, the value of the rational number remains same. Alright, so here let us take an example like 4 by 5. Alright, so if I multiply the numerator and denominator by same number, alright, same number and non-zero integer. So let us take 2, alright, 2. So here 4 into 2, 5 into 2. So it will be 8 by 10. And it will be equal to 4 by 5 only. Alright, the value of the fraction will remain the same. Okay, so here let us see how. For example, 8 by 10, let us divide it. Alright, they comes in a table of 2. So when I'll further cut it, so it will give me 4 by 5 only. So here standard form remains the same. Alright, standard form of 4 by 5 and this 8 by 10 is same. And in first point we have studied that if the standard form of two rational numbers are same, that means they are same. Alright, so I hope this point is clear to you. Now let us go for the third point. So here third point is, for example, 10 by 15. 10 by 15. Alright, so if I divide this number by 5, numerator by 5, so I have to divide denominator by 5 as well. Alright, so here divide by 5 and it will give me 10 divided by 5 will be 2 and it will be 3. So the value of the fraction will remain same. So here 2 by 3 is equal to 10 by 15. The value will remain the same because again the standard forms are same. Alright, standard form of 10 by 15 is 2 by 3 and 2 by 3 is 2 by 3 only. Alright, so whenever we are multiplying something to numerator, make sure that we multiply it by denominator as well. Alright, and same is the case of divide. Why? So that the value of the rational number remains same. Alright, so I hope these notes are clear to you. Alright, let's move further. So there is a question over here, fill in the blanks. Alright, so here 60 by minus 24 is equal to 5 by dash, that is the value of these two or standard form of these two are same, that is these rational numbers are equal. Alright, is equal to dash upon minus 120, that means these three rational numbers are equal. So we need to find the value in the blanks. Alright, so there are two methods over here, so we'll follow the two methods and whatever feels comfortable for you, you can go with that method. Alright, so here 60 by minus 24 is equal to 5 by dash. Alright, so our first method, okay, first method 1. So here I have to see that what should I divide 60 with so that I'll get 5. Alright, what should I divide 60 with so that I could get 5? It's 12, isn't it? So here in numerator what we did, we divided by 12. Right, okay. So we know that if I am dividing or multiplying something in numerator, I have to multiply or divide it in denominator as well. Alright, So if I'm dividing numerator by 12, I have to divide this denominator by 12 as well. Why? So that the value of rational number remains same. So here 24 divided by 12 will give me 2, and this plus minus will be minus. So here answer is minus 2. Alright. So I hope this method is clear to you. Alright. We'll go for method 2 now. Alright. So method 2. So here this dash by minus 120 is equal to 60 by minus 24, isn't it? So here I'm writing 60 by minus 24 is equal to minus 120, and there is a dash in numerator. Let us suppose it's x. Alright, so here I'm supposing it's x. Alright, so here what I have to do, I have to find the value of x. Alright, so just keep x on one side and take all the numerical value or all the numbers on the other side. Alright, so here 60 by minus 24 into this minus 120 is in denominator. So when I'll take into LHS, it will come in numerator. So it will be minus 120 is equal to x. Right. So here minus minus will be plus, and this will be divided by 5. 24 into 1 is 24. 24 into 1 is 24, and 24 5s are 120, right? So here 65s are 300, and that is our answer. Alright, so I hope these two methods are clear to you. You can follow any of the method, the answer will remain the same. Alright, so let's move further now. So our next topic is absolute value. Alright, the absolute value of a rational number is its numerical value without sign. Alright, numerical value without sign, that is we are least concerned about the signs. Alright, okay, so they are also known as modulus. Alright, they are also known as modulus, the other name of absolute value. Alright, now they are denoted as mod of a by b. That is the form we denoted. Like for example, mod of 2 by 3. So here this bracket, this box, this mod shows that we need to find the absolute value. Alright, so here 2 by 3, we are just least concerned about the sign. So write the numerical value. So here numerical value is 2 by 3, and that is our answer. Alright, let us take one more example. Minus 11 by 10. Alright, so we are least concerned about the sign. We are concerned about the numerical value. So minus 11 by 10. What is the numerical value? 11 by 10. Just remove the signs. So it will be 11 by 10. Alright, in a similar way, 7 by 5. Alright, so we are just concerned about the numerical value. So here answer is 7 by 5. Alright, in a similar way, let us take one more example over here. Minus 3 by 7. Now I have to find the numerical value. That's it. Alright, just remove the sign. So it will be 3 by 7. Alright, so I hope these examples are clear to you. Let us see some more example over here. Like minus 5 by 7. Alright, here minus 5 by 7. So we are least concerned about the sign. Just remove the sign. So it will be 5 by 7. In a similar way, 2 by 3. Just least concerned about the sign and just take the numerical value. So 2 by 3 is equal to 2 by 3 only. Alright, so I hope these examples are also clear to you. Let's move to the next topic. So our next topic is comparing two rational numbers. Alright, so here step 1 is to obtain the given rational numbers. Alright, whatever rational number is given to us, just write it back. Okay, then step 2, write the given rational numbers so that their denominators are positive. In a similar way we did it in standard form. Alright, we made the denominator positive. Alright, so we have to do it here also. Okay. Step 3. Find the LCM of the positive denominator of the rational numbers obtained in step 2. Alright, if the denominators are not equal, we have to find the LCM and make the denominators equal to LCM. That is, we need to find the equivalent fraction. Alright, so step 4. Express each rational number obtained in step 2 with the LCM obtained in step 3 as common denominator. Alright, so compare the numerator. Now what I have to do, I just have to compare the numerators of rational numbers obtained in step 4. The number having greater numerator is the greater rational number. Alright, so what we have to do, that when we are done with finding the equivalent rational number equal to the denominator as LCM, what we have to do, we have to just compare the numerators. Alright, and we'll get our answer. Alright, so we'll see these steps in detail with questions, but before that let us see some points that we have to remember. Alright, so here points to be considered. So here first point is every positive rational number is greater than 0. Alright, whenever we compare any positive rational number with 0, make sure that a positive rational number is always greater. Alright, so here 2 by 3 and 0. So let us say 2 by 3 is greater than 0 and that's it. Alright, so here 11 by 10 or 0. Which is greater? 11 by 10. Done. Alright, so I hope this first point is clear to you. Let's move to the second point. Every negative rational number is less than 0. Alright, whenever we compare negative rational number with 0, always 0 is the greater one. For example, minus 1 by 2 and 0. So just mark 0 as greater and that's it. Alright, similarly minus 5 by 7 and 0, which is greater? 0. Done. Alright, minus 11 by 3 and 0, which is greater? 0. Done. Within a second. Alright. Okay. Third point. Every positive rational number is greater than every negative rational number. Whenever we compare a positive rational number with negative rational numbers, positive rational number is always greater. Alright. So, like 1 by 2 and minus 10 by 11, which is greater? 1 by 2. Done. Positive rational number is greater. Alright. Then 5 by 7 and minus 3 by 7, which is greater? 5 by 7. Done. Within a second. Alright. Then minus 10 by 9 and 10 by 9, which is greater? 10 by 9. Positive rational number are always greater than the negative rational number. Alright. So I hope this third point is also clear to you. Now fourth point is every rational number represented by a point on the number line is greater than every rational number represented by points on its left side. So let us understand this point. Like we have a number line over here. Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and so on. So on the number line, the value of numbers get greater as we move to right hand side. Alright, as we move to the right hand side. For example, 4 is greater than 3, 3 is greater than 2, 2 is greater than 1, 0 is greater than minus 1. Alright, so I hope this point is also clear to you. Now let's move to the examples. Alright. So here our first equation is which of the two rational number is greater, 13 by 7 or 10 by 7. So let us write it over here, 13 by 7 and 10 by 7. Alright, when we see the denominators are already equal, isn't it? So we are not required to take the LCM. We take the LCM when the denominators are not equal. So here we are not required to take the LCM. Just compare the numerators. So here numerator is 13 and here numerator is 10. Alright, which is greater, 13 or 10? 13. So here 13 by 7 is greater than 10 by 7 and that's it. Our question is done. Alright, so I hope this question is clear to you. Let's move to the next question. So our next question is, which of the two rational number is greater, 3 by 4 or minus 2 by 3? So here 3 by 5 or minus 2 by 3. Alright. So here denominators are different. So we are required to take the LCM, but we can do it within a second without taking the LCM. How? How? Let us see. Alright. So here I can see that 3 by 5 is positive rational number. Positive rational number. And here minus 2 by 3 is negative rational number. Isn't it? And we have studied that positive rational number is always greater than the negative rational number, isn't it? So here this positive rational number is greater than negative rational number and that is our answer. Alright. So I hope this question is also clear to you. Let's move to the next question. So our next question is, which of the two rational number is greater? Alright. So here minus 3 by 4 and second is 5 by minus 6. Alright. So what is our first step? Yes, to make the denominator positive. So here step 1. Alright, step 1. Make denominator positive. Alright. So here it is already positive. So I am writing minus 3 by 4. And here it is minus 6. Take the negative sign to the numerator. So it will be minus 5 by 6. Right. So our first step is done. So we can see that the denominator of the two are different. Then what we have to do? We have to make the denominators equal. That is same. So for that what should we do? LCM, isn't it? So take the LCM of 4 and 6. So here 4, 6. It comes in a table of 2 and this is 3. This is 1. This is 3. This is 3. 1, 1. 3 2s are 6. 6 2s are 12. So LCM of 4 and 6 is 12. Alright. So what I have to do? I have to make this 4 as 12. Alright. Denominators. Alright. So what should I multiply 4 with so that it becomes 12? 3. Isn't it? So I have to multiply this 4 by 3 and I have to multiply minus 3 by 3 as well. Why? So the value of the rational number remains same, isn't it? So I have to multiply this numerator by 3 as well and I'll get 3 into 3, 9, 4 3s are 12 and this minus plus. Alright, the rational number has different signs. So signs of the result will be minus. So minus 9 by 12. Done. Now I have to make this 6 as 12. What should I multiply it with? 2. So here 2. Now I have to multiply minus 5 by 2 as well. So the value of the rational number remains same. So here 2. So it will be minus 10 by 12. Alright. So let us write it over here. Minus 9 by 12 and minus 10 by 12. Alright. So now how do we compare the negative number with negative number? Alright. So in negative number case, what we can do? I am writing 9 by 12 and 10 by 12 over here. Alright, positive numbers. I am just removing the sign and I am considering the positive numbers over here. So here 9 and 10, which is greater? 10. So when in positive 10 by 12 is greater, then in negative minus 9 by 12 will be greater. As soon as we change the sign over here of the numbers, the sign in the middle will get the opposite as well. Alright. So here in positive, let us just compare the numbers in positive. Alright. And here 9 by 12 and 10 by 12. So 10 by 12 is greater. That means that here in negative minus 9 by 12 is greater. Alright. This is the first method. And second method is in negative sign. Alright. Greater the value of the number, greater will be its negativity. Right. As the number increases, its negativity increases. And as the negativity increases, the value of the number decreases. Alright. So in negative, greater the number, lesser will be its value. So in negative, alright. So 10 is greater. That means 10 is less. Alright. So here minus 9 by 12 is greater than minus 10 by 12. So I hope these 2 points are clear to you. Alright, so now let's move to the next. So our next question is, arrange this number in descending order. Alright, so here descending order means that we have to arrange it from bigger to smaller. Alright, bigger to smaller. Alright, okay. So now our steps will remain same. Alright, so what was our first step? To make the denominators positive. So let us do that. So here our first number is 4 by 9. Second number is minus 5 by 6. Third number is what? Minus 7 by minus 12. I am writing the number right now. Alright, and this is 11 by minus 24. Done. Alright, so here let us make the denominators positive. It is already positive, so keep it as 4 by 9. Alright, here minus 5 by 6, it is again positive, keep it as minus 5 by 6. Alright, minus 7 by minus 12, so minus will get cancelled out and it will get 7 by 12. Alright. And this 11 by minus 24, this minus will get into the numerator. So it will be minus 11 by 24. Done. Our first step is done. Now I can see that the denominators of all the numbers are different. So what should we do? Yes, LCM. So let us take the LCM of 9, 6, 12 and 24 over here. Alright, so here 9, 6, 12, 24. So here it comes in a table of 2. So 3, 9, 6, 12. Then 2, 3, 9, 3, 6. Then 2, 3, 9, 3, 3. Then 3, 1, 9, 1, 1. 3, 1, 3, 1, 1. 3. Then 1, 1, 1, 1. Done. So here let us multiply them. So it will be 3 3s are 9, 9 3s are 27, 27 2s are 54, 54 2s are 108 and 1028 into 2 will be 216. Alright. So here LCM is 216. Done. Now what I have to do? I have to just make the denominators equal to our LCM. So that is equal to 216. Alright. So let us start. So here I am just removing this part so that I get the number. Alright. So now our first denominator is 9. I have to make it as 216. Alright. Now I am getting confused. What should I multiply 9 with? So that I could get 216. So for that what we can do? We can simply divide 216 by 9. Alright. 216 by 9. So it will be 9 2s are 18, 36 and it will be 24. Alright. So you have to multiply 9 by 24 to get 216. Alright, so just divide the number. Alright, so here 24. So I have to multiply numerator by 24 as well. Done. Alright. So here 24 into 4 is 96. So here 96 and it is 216. Done. Alright. In a similar way, I have to make 216. 6 as 216. Now I'm again confused. Right. So simply divide 216 by 6. So it will be 6 3s are 18 and it will get 36. That is 36. Alright. So I have to multiply 6 by 36 to get 216. Alright. So if I'm multiplying this by 36, I have to multiply numerator by 36 as well. So it will give me minus 180 and this will be 216. Alright. Okay. Now 12. What should I multiply 12 with so that I could get 216? What we can do? We'll just simply divide 216 by 12. So it will be 216 by 12. So it will be 12 and the 12, 96. That is 8. 18. So multiply 18 to the numerator and denominator. So our 18 into 7 is 126. Right. So here it will be 126 and 18 into 12. 18 into 12 is 216. Right. Alright. Okay. So here this will be 24. Now 24, what should I multiply 24 with so that I could get 216? 9. So multiply numerator and denominator by 9. So it will give me minus 99 and it will be 216. Done. Alright. So now what we have to do, we have to simply compare the numerators. So now let us compare the numerator part. Alright, we have to arrange it into descending order, that is bigger to smaller. So we know that the positive numbers will be the biggest one. So here let us compare the positive number first. So here I can see that 126 and 96. 126 is greater, that is our biggest number is 126. So here I am writing 126 by 216 is greater than 96 by 216. Done. Our next step is to compare the negative numbers. Alright, so minus 180 and minus 99. We know that in negative number, greater the number, lesser will be its value. Isn't it? So therefore minus 180 will be the lesser number, right? Smallest number. So our next number is minus 99 by 216 and here minus 180 by 216. Done. Now just convert it into standard form again. So 126 by 216, it's equal to 7 by 12. So let us write 7 by 12 first. Then 96 by 216, that is 4 by 9. So write 4 by 9 second. Then this minus 99 by 216, it will be minus 11 by 24. So minus 11 by 24. And the third one is this minus 5 by 6. So write minus 5 by 6 and that is our answer. Alright. So I hope this question is clear to you. Let's move to the next question. So our next question is, which number is in the middle when this number is arranged in descending order? Alright. So let us arrange them in descending order. Alright. So what is our first step? What is the first step? Yes, to make the denominators positive. So here I am writing the numbers minus 1 by 6, 4 by 9, 6 by minus 7, minus 3 by 4 and 2 by 5. Right. So here let us make the denominators positive first. Alright. So here minus 1 by 6. Minus 1 by 6 denominator is already positive. What we don't have to worry about it. 4 by 9, 4 denominator is positive. 6 by minus 7, take this negative to the numerator. So it will be minus 6 by 7. Done. and here minus 3 by 4 and here 2 by 5. Alright, now what we have to do? We have to take the LCM because the denominator of each and every number are different, isn't it? So here let us take the LCM of the all the numbers in the denominator. So LCM of 6, 9, 7, 4, 5. Alright. So here I am writing 4, 5, 6, 7, 9. So it goes in a table of 2. So 2, 5, 3, 7, 9. Alright. Again it goes in a table of 2. 1, 5, 3, 7, 9. Then 3, 1, 5, 1, 7, 3. Then 3, 1, 5, 1, 7, 1. 5, 1, 1, 1, 1, 7, 1. 7, 1, 1, 1, 1, 1, 1. Alright. So here let us multiply them. So it will be 7 5 35. 35 2s are 35 2s are 70. 70 9s are 7 9s are 63. 630. 630 into 2. It will be 1260. Alright. So our LCM is 1260. Alright. So what we have to do? We have to simply make the denominators equal to 1260. Alright. So here let us start. Okay. So here minus 1 by 6. I have to make 6 as 1260. What should I multiply it with? 210. So multiplied by 210. So here 210, 210. Alright, it will give me minus 210 and it will be 1260. Done. Now I have to take 9 as 1260. Alright, what should I multiply it with? 140. Alright, so multiply the numerator and denominator by 140. So it will be 560 upon 1260. Right. Now what I have to do? I have to make 7 as 1260. What should I multiply it with? 180. So multiply it by 180. So here 180 into 6 is 1080. So it will be minus 1080 upon 1260. Alright. In a similar way, I have to make this 4 as 1260. Alright. What should I multiply it with? 315. So multiply the numerator and denominator by 315. Alright. Here I am removing this 2 by 5 and I'll write it over there. And it will be equal to 315 into 3. It will be minus 945. Alright, and here it will be 1260. Alright, now our next number is 2 by 5. Alright, so here 2 by 5. Alright, what should I multiply 5 with to make this 1260? Alright, so it will be what? 1260 divided by 5. Just divide it. Alright, whenever you are confused, just divide it. So it will be 5, 2, 26, that is 5 again, and it will be 5 2s are 10, then 26, 5, 252. Alright, 252. Alright, so here multiply the numerator and denominator by 252. So here I'll get 4, 5, 0, 5, 0, 4 and it will be equal to 1260. Done. Alright. Now what we have to do? We have to simply compare the numerators. So let us do that. So here what we have to do? Just write it over here. And we know that we have to arrange it into bigger to smaller. So positive number will always be the bigger one as compared to the negative number. So let us compare the positive number first. So here 560 then 504. Alright, these are the two positive numbers. So 560 is greater. So let us write 560 by 1260 is greater than 504 1260. Now let us compare the negative numbers. So in negative number, greater the number, lesser will be its value. Right. So I can see that the smallest number is minus 210. So it will be what? Greater in value. So here next number is minus 210 upon 1260. Then next will be minus 945 and here minus 1080. Which will be greater? The number which is smaller, that is minus 945. So minus 945 1260 and the last one is minus 1080 upon 1260. Alright, so now let us write it into the standard form and we have done our work. So here 560 by 1260 is equal to 4 by 9. Here 504. Alright, it is equal to 2 by 5. So write 2 by 5 over here. Then minus 210 is equal to minus 1 by 6. So write minus 1 by 6 over here. Minus 9 by 4, that is equal to minus 3 by 4. So write minus 3 by 4 over here. And our last number is this, minus 6 by 7. So write minus 6 by 7 over here. Done. Alright, so our first part is done to convert it into descending order. Alright. Now what we have to do, we have to find the middle number. So here our middle number is minus 1 by 6. So therefore our answer is equal to minus 1 by 6. Alright. So here what we have to do, we need to arrange it into descending order, that we have done. And then we found the middle number. Alright. So I hope this question is clear to you. Alright. So this is the assignment related to the question and concept that we have studied today. Alright. So do as much question as you can so that this concept is clear to you. I hope this lecture is clear to you. Thank you so much.